our 5th class, and I'm going to show you now to how it would happen after we have first a gasoline spill on top of capillary fringe, then we added ethanol. Now we're going to raise the water table and check further what happens. So I'll first release the movie and then we'll talk. Take a look. I'd like to remind you again that this was produced by Juliana Freitas, as I mentioned, previous Waterloo PhD student. Now she's working at the University of Federal of São Paulo. Well, what I'm going to show you here, and I want you to understand, is again the behavior when you have more than one component and one is a co-solvent like ethanol. Well, what happens is, when we added ethanol, we changed it and we had that composition, actually we decreased the interfacial tension. Now, as the water table raises again, we see the original, take a look at that. That's the original position of the water table, and that's the final position of the water table. Okay? So the final position of the water table, what happens is that as the water table is raising back to its original position, it is displacing ethanol and a little bit is mixing and it's changing the composition of the gasoline phase and water phase that we had previously in the pores, right? As you had water and gasoline phase in the ternary diagram, as you add more water, you tend to separate and create different phases, and you increase the interfacial tension back as you have more water mixing with that composition. Previously you had a higher concentration of ethanol. Now as you add more water, you end up having a higher proportion of water, and then you separate more the phases. You can see that in the ternary diagram. They were up here and they go a bit down. So you separate, you increase the interfacial tension. As you increase the interfacial tension, you end up having more residual phase. And that's what we see here. So I'll repeat that. So it is increasing. You see more red points appearing here. Red is gasoline phase, right? So we see more residual phase appearing. So, although we have some co-solvent mixed with gasoline and water that develop more of a mixing and reduce dramatically the interfacial tension, as the water table raises back, well, what we have is that again the composition goes more towards the water phase and you tend to separate back, increasing the interfacial tension between these two phases, the gasoline phase and the water phase, and you have more residuals. That is quite common in situations like in US and in Brazil, where you use ethanol as a fuel of choice as well. And you have ethanol spilled in the subsurface with mixed with gasoline and water. This is a very complex situation, but as water table fluctuates in time, you end up having more residual phase again. And since ethanol tends to partition to the water phase, this ethanol leaves with it more dissolved phase of gasoline, but the gasoline that is left behind would be less rich in ethanol. We will have a lower concentration of ethanol, or a lower percentage of ethanol in that case. And it becomes higher in interfacial tension and it becomes a residual phase again. As this stays happening throughout the years, you end up with residual phase that has less ethanol and it becomes similar to a gasoline. The only difference is that you are likely, as you see in this picture here, to have more residual, more evenly spread region of residuals of gasoline in a field with some ethanol. Biodegradation of that would be a bit different due to the relationship of ethanol electron receptors to the gasoline. But that is Jim Barker's subject. I'm not going to go into that. So these videos are very important, and although you may not use eco-solvent flush based on reducing interfacial tension as your remediation of choice, I do recommend that you study that, because learning the relationship between interfacial tension and how free to residual phase are related, you can actually improve very much your understanding of your remediation and how you're going to end up with residual phase every time you try to extract your free phase. Okay? This is very important. And let's see some of the remediations then that we have here for our application of ethanol. That's going to be our next class. Thanks.